Students, whoever thorough with the organic concept, this video is for you. This video we are going to discuss the top 50 organic questions. If you answer each one of these questions in 10 to 30 seconds, then you can score 150 marks plus in your chemistry of NEET. Okay, so let's get started with the first question. How many aromatic isomers are possible for trichlorobenzene? Pause the video for 10 seconds to try to solve it. I'm giving you the answer, which is there are 3 isomers possible. This 1, 2, 3 and 1, 4, 1, 3 and 5, and another possible configuration is 1, 3, 4. Okay, so these 3 configurations possible for C6H3Cl3, right? So answer to this question is option B. Then moving on to the next question, the decreasing order of basic strength of X, Y and Z. Very simple question. Take only 15 seconds to solve. If you know the key concept of this question. What is that? So you could see here I'm having lone pair. This nitrogen is also having lone pair. And this nitrogen is also having lone pair. So what is the key concept of this question the examiner is asking is that cyclic amines are more basic than the tertiary amines, right? So if you are seeing here, this is undergoing conjugation also. The first one, that is sp3 hybridized, correct? sp3 hybridized. This is when that is undergoing the conjugation. It becomes sp2 and this is sp2. So what is the order of basic strength over here? Yes, the answer is X, then comes Z, then comes Y, right? Okay, because of the conjugation and the cyclic amine concept. Moving on to the third question, rank the following in decreasing order of basic strength. Once again, the question with basic strength. This will take only 15 seconds. You should take only 15 seconds. What is the answer to this question? Check for the negative species: carbon, oxygen, sulfur. These 3 are here, right? So comparing carbon, oxygen, sulfur, which possesses the negative charge which is suitable for that? And one more concept here you have to see about this size. Sulfur is bigger in size when we are compared with oxygen, right? So I'm giving you the hint for these type of questions. Okay, so the basic strength, always, we already saw this in our one shot of inorganic and organic also. The basic strength is inversely proportional to stability of anion, right? And inversely proportional to dispersion of negative charge. What is mean by dispersion of negative charge? So let's say sulfur. Sulfur is larger in size when we are comparing with oxygen, right? So the negative charge is well dispersed. Compare the sulfur of a big house and the oxygen which is having a small house. Okay, so that is the dispersion of negative charge, and which is also basic strength is also inversely proportional to electronegativity. Okay, now tell me what is the correct order. A, that is less stable, so which makes more basic strength. Okay, so either of C or D, then comes D. Okay, here you can see C double bond O, O minus, correct? So then it should go with B and finally C, right? Okay, so moving on to the next question, which is not electrophile in nature. Very simple question, just a 5 second. So don't mess up with only stick with the positive charge. Here, this is having a vacant orbital. Electrophile, which is the electron loving species. The vacant orbital also works, right? So C H3O plus. I already told you NH4 plus and H3O plus. Although those are having positive charge in it, these are not electrophiles. Okay, answer is option D. Then, which is not correct for a nucleophile? Okay, nucleophile is that a Lewis acid? No. right? Nucleophiles are the electron-rich species, right? So, which can able to donate, which is a Lewis base. Think of it, ammonia, right? That is a Lewis base which is having a lone pair in it. So absolutely, this becomes our right answer. You can see the other things as well. Ammonia, that is having a lone pair in it. The nucleophile attack the low electron density center, of course, and nucleophile are not electron seeking. They are not electron seeking. They are already rich in electrons. Then comes geometrical isomerism is shown by, just quick, only it should take 10 seconds. These type of questions just to see where is the double bond. Okay, where is the double bond? Here I'm having a double bond. Okay, this carbon and this carbon is our main focus. This carbon is having 2 hydrogens, so obviously not the correct answer. This carbon is also having 2 hydrogens. The geometrical isomerism should have different molecules or elements attached to it, right? Then CCl2, obviously this is not. What about this? CHCl. Let's take the another part also. So you can see this goes like this, and this side I'm having a substitution which makes it differ. So answer to this question is option D. Then which will exhibit cis-trans isomerism? So cis-trans isomerism, once again, so here I'm having 2 butene, right? Okay, then butanol. Butanol, obviously it will not work. Cis-trans isomerism is part of geometrical isomerism, so which should have a double bond in it. So butene, 2 butene, CH3, CH double bond, CH, CH3, right? So answer to this question becomes option A. Which will exhibit geometrical isomerism? Once again, ma'am, why these questions are? These are the repeated questions which was asked in AMPT and NEET and other examinations also. Okay, then which will exhibit geometrical isomerism? 1,1 diphenyl prop 1-ene. This test your nomenclature as well as the isomerism part, right? So take 10 seconds of your time to solve this question. Here I can give you a simple trick. So whenever the substitution is having a same number, okay, 1,1 diphenyl propene. So propene, 1 propene, is it? So 1,1 diphenyl, 1 propene. So both the substituent of the carbon which is same over here. So which makes it, or this makes it eliminated from the competition, right? So this will not. And what about 3-phenyl 1-pent-ene, pent 1-ene, 3-phenyl pent 1-ene, CH3, CH2, CH2, CH double bond, CH2, and 3-phenyl. So here you can see where is the double bond. Double bond is our main concern. CH2 is there, and similarly in 2-phenyl 1-pent 1-ene also the case will be the same. What about the last option, D option, which is having 1-phenyl 1, 2, 3, 4, 5, 1-phenyl pent 2-ene, pent 2-ene, 1-phenyl. Okay, so this side I'm having hydrogen and another group. This side I'm having hydrogen and another group. So this can exhibit geometrical isomerism, right? So this kind of easy questions only they will give. So don't get worried. Please be motivated. How many stereoisomers it can exhibit? Very, very, very simple question. Stereoisomers, which includes geometrical and optical isomers also. So this is one chiral center. So here I'm having double bond. I think this is the molecule. So how many stereoisomers are possible over here? So this can give cis and trans, and cis and trans can give D and L isomers. Cis can give D and L isomers. So total 4. 2 geometrical, 2 optical. Then which molecule expected to rotate plane polarized light? Find it out which is chiral center. As simple as that. Just a 5 second is enough to answer this question. Both are same, so not an answer. What about this? This is a chiral center, just be an answer. Both are same, not a chiral center, so that can't be the answer. Let's say this question. Alkyl chloride with sodium triether. So what would be the product? That's what the question is. What is this reaction? This is a Woods reaction. Right? Woods reaction is for higher alkanes. So what that will do? So just to count the number of carbons, 1, 2, 3, 4. So just check. This Cl will take up Na and go. So 2 Na should participate in the reaction. 2 moles of the reactant will go. So 4. So what would be the right answer? 1, 2, 3, 4, 5, 6, 7, 8. So option C becomes the answer to this question. Moving on to the next question. In the reaction with HCl, an alkene reacts with accordance with the Markovnikov rule to give a product of 1-chloro-1-methyl cyclohexane. So cyclohexane, which is having 1-chloro-1-methyl. Okay. The possible alkene is Markovnikov rule. What is that? The negative adenine will go to more substituted site. Right. Here you can see what could be your answer. If I'm having this, then hydrogen will go here and Cl will go here. This could be our answer. Or this type, then again hydrogen will occupy here, Cl will go here. So this could be our answer. So answer to this question is A and B. Clear? Then which alkenes on ozonolysis gives CH3, CH2, CHO and acetone? So ozonolysis, I already told you, if there is a double bond, break the double bond, put double bond O on both the sides. Okay. So let's see how this goes. CH3, CH2, CHO. And here I'm having CH3. So if I'm breaking this will lead to the compound like this. 1, 2, 3 carbon, which is CHO1 and acetone 1. Option A seems to be right. Let's take other options as well. So this will give 2 aldehydes. And this will also give 2 aldehydes. Right? And what about this? This will give you one aldehyde and another one is ketone. But if you could see, the ketone is acetone and the aldehyde is CH3CHO. This is the end product. So our end product is having propanaldehyde. So option A is the answer to this question. Moving on to the next question, the single compound of the structure given below obtained by the ozonolysis of which of the following cyclic compounds? So they have given you the product and asking you to find the reactant, right? Okay. So you can see the options are cyclic in nature. So which suggests you that you have to go about aldehyde and this ketone part must be a double bonded system before, right? So I'm going to draw the structure that is having a double bond and coming to this part 1, 2, that side I'm having a methyl group and then 3, right? 2 I'm having methyl group and then 3, 4 is connected with this carbon. So which is similar to this? 1 and 3rd position substituent would be there and 1 position is having a double bond. So answer to this question is option D. So if you're breaking it also, you will get the same, right? So double bond O, this will become this part and this part is our aldehyde. Then 15th one. So ozonolysis must be there in your question paper. Whatever the exam, whatever the year you are writing, ozonolysis is very, very important. Here you can see ozonolysis with hydrolysis. So here I'm having triple bonded system. Ozonolysis followed by O3 followed by hydrolysis. So what you can expect? Here I'm having CH3 triple bond C, CH2, CH3. Followed by hydrolysis means you are going to break the bond and that product will undergo again oxidation. So as you can see, this will give you aldehyde, this again will give you an aldehyde. So that undergoes an what I can say, that is oxidation, so lead to the formation of carboxylic acid. So answer to this question becomes option B. Then C6H5CH3Cl. What is this reaction? Very simple question. Friedel-Crafts alkylation. Right? Gold synthesis is something different, deals with the salt. Woods reaction or high level in taking two RX leading to the formation of high level of alkanes. Woods fitting, where I am taking aryl halide and alkyl halide to form a benzene with the substitution of R2. So answer to this question is option D. Then let's see who solves this question. This question is, you can expect this kind of question. Bit tricky, but you can solve it. Very simple question if you know the electronegativity concept. So usually what they will do with the chlorination part or halogenation of this is an electrophilic substitution reaction, isn't it? So they will give you Br2, Cl2, like that. But here I'm having ICl, two different halogens. So whenever they are giving you Cl2, what you will do, this AlCl3 will take up one of those Cl minus, right? Remaining Cl plus will be there, that will act as an electrophile, attack the benzene ring. Here I'm having ICl, so which is plus, which is positive, which will be negative. More electronegative atom will be negative and another one will be positive. Among these two, which is more electronegative? Of course, our Cl become electronegative and I is becoming an electrophile over here. So answer to this question becomes B. Which of the following compounds will not undergo Friedel-Crafts reaction easily? So as you can see, I'm having orthoxylene and nitrobenzene, toluene, cumene. Man, these cumene, I don't remember the structure, orthoxylene, I don't know at all. Don't worry, just to see. Here I'm having nitrobenzene. What is Friedel-Crafts reaction? Electrophilic substitution, isn't it? Electrophile substitution means it needs electron-rich position. So if I'm having nitro group on the benzene ring, it will pull up all those electrons. So the ring becomes electron deficient. So which makes it little tougher for the incoming electrophile to attack. Okay. So without thinking about others, you can go with nitrobenzene. So for your information, I'm giving you orthoxylene is nothing but 2-methyl substituted one, and cumene you know about this guy, and toluene C6H5 CH3. Elimination of 2-bromopentane to form 2-pent-2-ene is what type of reaction that is? 2-bromopentane 1, 2, 3, 4, 5. 2-bromopentane, which is giving us 2-pentene. What had happened over there? Bromine and one of those hydrogen got lost, got eliminated. So is this the beta elimination? Yes, this is beta elimination. It can go with this hydrogen as well, but it just went with this hydrogen because of Zaitsev rule. And HBr got eliminated, which is nothing but dehydrohalogenation. This is not a dehydration at all because H2O is not getting eliminated. So answer to this question is ABC, or that is option A. Then, which will not give Lucas test? Lucas test, the reagent is anhydrous zinc chloride with HCl, right? So tertiary will perform easier, then comes secondary, then comes primary. So which will not give? This is what type of alcohol? Secondary, and this becomes tertiary. And what about this guy? C. D, we know that is primary. What about C? Here comes the GOC part. Have you ever heard about Ritz rule? Which talks about the carbocation on bridgehead position is not possible. Right? So which makes this will not gives Lucas test, and that makes this correct. Then let's say this question, this can be prepared from Williams synthesis. What are the reactants they are asking? Okay, so what about Williams synthesis? It's just a reaction between alcohol and our sodium will react to give RONA that reacts with RX to form a product. Okay. So what type of mechanism it is involving? That is SN2. So if that is SN2, then what is our RX? SN2 favors 1 degree alkyl halide, right? So which makes, what is the answer? Which makes option B is the right answer to this question. Moving on to the next question. This is from a named reaction. If you know, just comment it over there. What is the name of this reaction? C6H5COCl HO2BDBSO4 gives A. Very simple question. Just seeing the question, you can pick the answer. That is option A. Aldehyde synthesis. You must know about this named reaction. Okay, I have told you n number of times. Then this question talking about CH3, CH2, CH2Cl in the presence of X. That is our reagent. Okay, reagent to give CH3, CH2, CHO. You can see one carbon less in the product. Okay, so then what is the reagent used over here? Tin Cl2, HCl, H2O with boiling. Again, BaSO4. In the last question only, we saw that goes for COCl, acyl chlorides, lithium aluminum hydride with ether, sodium borohydride with ether. This reaction, I think you already know, which is Stephan reaction for the preparation of aldehyde from cyanide. So what that will do? That will give you one carbon less, and the reagent is SnCl2 with HCl. Which of the following reagent is used to convert ethene nitrile to ethanol? Nitrile to ethanol. So once again, this is a substitution for SnCl2. So as you can see, this is just a conversion of our nitrile group to ethanol, right? Aldehyde. This question, which of the following reagent is used to convert ethene nitrile to ethanol? So ethene nitrile, which is nothing but CH2, CHCN, that is giving us ethanol CH3CHO, right? So you can see both ozonolysis. Will that give you? No. That will give you, if that is having the CN, so that won't be the possible way. And PCC, that is a mild oxidizing agent, that will not do anything with this. Anhydrous CrO3, that is called John's reagent, which will convert primary alcohol to COOH and secondary alcohol to ketone, but that will not do this. What about diol H? Diol H, which is diisobutyl aluminium isopropoxide, which is a substitution or the alternate for SnCl2. That is the right answer to this question. Then, which does not give yellow precipitate with iodoform test? So you can see iodoform test. I have told you so many times, but still I'm telling you, super important. A trick is there. Whenever you are having an aldehyde or ketone, if you are having alcohol also, that will get converted to our carbonyl group and then proceed with the reaction. So that should have a CH3 group, the whole CH3 group in either the side. Okay, so let's say acetaldehyde or acetone. So those molecules will give you the positive to iodoform test. Positive to iodoform test means that will form yellow precipitate, right? So here you can see propane 2-ol. So propane 2-ol, that will give you acetone, that can give iodoform test. And butane 2-ol, once again, 1, 2, 3, 4, 2-ol, that can also give, because this side I'm having CH3. Pentanone, pentane 2-on, once again, that is also having CH3. Pentane 3-on, what about this molecule? That is not having a CH3 on either of the side. So that will not give you positive to iodoform test, which makes the answer to this question is option D. Then 25th question. Question seems to be a bit tricky, but it is not. Just check out the options as well. If you can, just tell me the answer. X is reacting with copper to form A. A is undergoing the base and a heat reaction to form Y, and then semi-carbazide reaction to give Z, and it is showing the silver mirror also. So just check what could be the answer. Done? So the first one, X is giving you A. A is giving you the silver mirror test. That is the main clue over here. Okay, silver mirror test, who will give that? Aldehyde, right. So we have to look for the A which is having an aldehyde group. So the first A, that is methoxymethane, that is an ether, no. The second option, that is saying ethanol, that is having an aldehyde group, this could be our answer. And C, ethanol is there, and D, again methoxymethane. So without knowing any other reaction, you can take the answer, that is option B. Let me give you the answers for other one also. This is tolerance test that we know, and what could be the X? If A is ethanol, then X is ethanol, right? And what about this? This is an aldol reaction, which will form aldol or alpha beta unsaturated aldehyde or ketone, and this is semicarbazide, right? Okay, so let's check out Y, that is butene, okay, alpha beta unsaturated thing, and Z is semicarbazide. Should have a aldehyde, but anyway, the answer to this question is B. Then this one, aldehyde with ketone, it's undergoing NaOH. So what would be our product? What is the name of this reaction first of all? Aldehyde with ketone. It is enolite formation will happen, and alpha beta unsaturated aldehyde or ketone should be our product, right? Aldol condensation, you have CH3 alpha hydrogen over here, so that would be our enolite formation point. So 2 benzene rings must be there and aldehyde group must be there, so definitely that's not option A. And check for other options. This is not having any aldehyde or ketone group. And what about option B or C? C is having an extra methyl group, so which can't be our answer. And what about B? So that can be our answer, that is having alpha and beta unsaturated ketone is there. Then what is the answer to this question? It is undergoing H2 gas, 1 ATM, PD, C, ethanol. Here I am having double bond O and alkene. So which will get affected and which will not, or both will get affected? You can see this will affect only our double bond, the alkene system, not the double bond O. Then this question, just a conversion of CHO to COOH. So what could be the reagent? Tollens reagent or PCC? PCC will not give this reaction. Iodoform reaction or tin NaOH. Obviously tin will not. Tin will give you the reduction only, and PCC will not. And iodoform, will that give? No, it is not having any CH3 group, free CH3 group. So answer to this question is tolerance reagent. Positive carbylamine test is given by. So carbylamine is just for a primary amines. So N, N dimethyl aniline, N, N, that point only you can eliminate. 2,4 dimethyl aniline, 2,4 dimethyl aniline. Let's check with other options as well. N methyl aniline, no, that is becoming a secondary amines. So not the answer, none of these, obviously not. So which makes option B as your correct answer. Best method for preparing primary amines, alkyl halides without changing the number of carbon atoms in the chain. Without changing the number of carbon atoms in the chain, that is more important. Here you can see Hofmann-bromamide reaction, which is also called as Hofmann degradation, which means 1 carbon less. Amide will lead to the formation of amines. Gabriel-Thallamide synthesis. Okay, so which will involve the thallamide to form primary amines. Sandmeyer reaction. Sandmeyer reaction, which will form benzene diazonium salt, and then reaction with ammonia. So this can give you the option D. Then this kind of simple question can also be asked, not so simple but lengthy. Aniline with NaNO2, that will form diazonium salt, right? and with CuCN, C6H5, CN will be formed. Then again HNO2. Okay, again with a nickel hydrogen, this will form C6H5, CH2NH2. With nitrous acid, this will give you C6H5, CH2, supposed to be diazonium salt of aliphatic amines, but it is not stable, which will lead to the formation of alcohol. So let's check the option. Option is D. Diazonium salt with aniline, which is forming an yellow dye. What would be our product? So you need not to know about the yellow dye. You must know how the reaction proceeds. So most of the students will do the mistake. The Cl will take up this hydrogen to form a product like this. But it is not true. This will form a product but by taking up the hydrogen from the benzene ring. So answer to this question is option D. The technique used to separate the components of mixture on their different rates of migration in a mobile phase through the stationary phase. If you see these wordings, close your eyes and take the answer, that is chromatography. No other point to be discussed over there. In paper chromatography, this question, I have picked you this question because I don't want you to lose any of those marks just because of the simple calculation of RF value. It's nothing but the distance moved by the compound by the distance moved by the solvent. Okay, the compound moved distance by compound by solvent. Okay, so that is our formula. So distance of the compound, that is 12, and the solvent just moved 15. So which will give you the value 0.8 is our answer. Very simple question, but since you're not concentrating about POC, you are losing this mark. Then in steam distillation of mixture of orthonitrophenol and paranitrophenol, which isomer will distill first and why? So which will distill first, which is having low boiling point, right? Which will having low boiling point. So which will have low boiling point? For the first option says orthonitrophenol because of high boiling point. No, that can't be the answer. Orthonitrophenol because of due to intramolecular hydrogen bonding. This can be our answer because if you could see orthonitrophenol, that is having a hydrogen bond over here which is intramolecular. But in case of paranitrophenol, that is intermolecular hydrogen bonding is formed. What this will do, this will lower the solubility so that it can distill more easily. So which makes option B is your right answer. Then 3 grams of benzoic acid were recrystallized from hot water. After drying, 2.7 grams of purified benzoic acid were observed. What is the percentage yield? Which is the question related with the mole concept as well. So the percentage yield, which is our actual yield by theoretical, right? So actual yield, that is 2.5, 2.7 and 0.3 grams of benzoic acid, which makes 90% as your answer. Cool. Then a student observed the following properties of an organic compound. Water soluble, reduces swelling solution and forms a silver mirror with tolerance reagent. The compound could be, so reduces swelling solution, that is should be a carbonyl compound, that is also aldehyde, and forms a silver mirror with tolerance reagent. Once again, what about benzaldehyde? Let's see. Acetophenone, no. Glucose can be because that is having a free aldehyde group. Sucrose, that is not having free aldehyde group in its texture. By hydrolyzing the sucrose, you may get glucose and fructose that will have aldehyde and ketones. For now, sucrose is not. Glucose and benzaldehyde. The key over here is water soluble. Benzaldehyde is not water soluble. Not much water soluble as glucose. So which makes glucose is our answer. Which of the following statements is incorrect about DNA? The sugar in DNA is 2-deoxyribose. True. 2 strands are held together by hydrogen bonds. True. Adenine pairs with thymine through the 3 hydrogen bonds of DNA. 3 hydrogen bonds. Okay. DNA replication is semi-conservative. Okay. So you can see the option C, which says adenine pairs with thymine through 3 hydrogen bonds. A, adenine with thymine, which is not 3 hydrogen bonds, that is just 2 hydrogen bonds. But in case of guanine with cytosine, that will give you 3 hydrogen bonds. Okay, so which makes answer to this question is option C. And know about option D as well. DNA replication is semi-conservative, which means that one strand would be from our ancestor DNA and another strand is new. So that means the semi-conservative. Then, which of the following compounds not undergo aldol condensation? Aldol condensation means that should have a alpha hydrogen in it. Acetophenone, yes, that can give you diethyl ketone, which is having alpha hydrogen in it. Yes. Benzophenone, no, right? So benzophenone, that is not having any alpha hydrogens in it, which makes option C is your right answer. Acetaldehyde, it can, CH3CH2. Which of the following conversions involve Claisen condensation? So condensation is happening over here. 2 moles of ester we just took. So just check for the options which can give you the condensation. Obviously, it is not option D, not option C. And what about option B, that is cross-aldol condensation? So it is not our answer. And option A, Claisen condensation, which will give you ketoesters with alcohol. Sandmeyer reaction for converting aniline to chlorobenzene. Which of the following statements are incorrect? Reaction proceed to disonium salt intermediate. True. CuCl acts as a catalyst for the reaction. Yes. Reaction can be performed at room temperature. No. So reaction must be maintained at 0 to 5 degrees Celsius because of benzene disonium chloride is not at all stable at room temperature. So which makes option C as your right answer. Consider the following reaction sequence. Benzaldehyde with quinoid reagent gives A. Okay. Then that is undergoing hydrolysis to form B. So let's see the first step, CH2 MgBr. So this part, which is minus over here, that will attack, that will form a magnesium intermediate. Then that is undergoing hydrolysis, that will give C6H5, CH2CH3, and with PCC, that is forming C. So this is a secondary alcohol that will give you ketone. So let's check for the option which is having ketone. Either A or D. 1-phenyl propanone or 3-phenyl propanone. Which is right? So of course the lower localent rule, 1-phenyl propanone, which makes an answer to this question. See this question, in a Hoffman bromide reaction, what is the correct order of following steps? So I'm giving you this question as your homework. You know about Hoffman bromide degradation reaction, right? The big mechanism. So which involves these steps. If you done it right, I will give you the mock test paper. Okay? I will send you the link of mock test paper. Just comment over there which is the right answer to this question. Okay? Moving on. Tetrapeptide has the following amino acid composition: alanine, lysine, phenylalanine and glycine. How many different tetrapeptide can be formed? Very simple question, but most of the students skip this question just because they don't know it. Here I am having 4 different amino acid. So just do 4 factorial. Ma'am, what is that? We are biology students. So nothing. 4 factorial means just you have to do 1 into 2 into 3 into 4. Right? What is the answer? 2 into 3, 6. 6 into 4, 24. So 24 is our answer. In the Clemmensen reduction of ketone, which of the following statements is incorrect? So amalgam is concentrated. HCl is used for reducing agent. The reaction proceeds by a carbocation intermediate. The reaction involves complete reduction of carbonyl group. The reaction works well for aryl ketone. Amalgam, zinc amalgam is used as a reducing agent, and the reaction proceeds by a carbocation intermediates. No, that is not true. This will undergo zinc oxide intermediate, and C and D are right, which makes option B is your correct answer. So that's it for today. I have given you the question. Just to answer to that question, I will give you the mock test paper link. Okay, please practice more and more questions. The inorganic set is going to come. Please stay tuned. Thank you.